DevSecOps ecosystems, workflows, and pipelines. The DevSecOps ecosystem is, everything that is relevant when you're talking about DevSecOps. And so it's not only the, the pipelines, but also the things that it depends on the surrounding processes and things that are necessary to understand to really do DevSecOps properly. So it's certainly a collection of tools, workflows created and executed on those tools to support activities throughout the whole DevSecOps, life cycle. The DevSecOps ecosystem is comprised of, planning, pipeline, production, operations would be included in that ecosystem. If you look at the diagram, this is a diagram from the Department of Defense document that we talked about earlier, which again I think is a pretty well documented view of DevSecOps. One of the better ones, pretty logical. Thinking about, who is the mission at the top, the Dev, Sec, and Ops are the main players. And even though planning is not part of a pipeline, it does have an impact on how to put together a pipeline and what is, how to get ingest artifacts into the pipeline from planning requirements, project plans, not only for the application changes, but even for the pipeline itself. Then you have what was called in the prior slides in the earlier modules, the software factory, which is kind of that infinite loop, development, building, testing, releasing, and delivering, and all the different technologies and processes, people aspects involved in that. That's probably the core, if you like, of the DevSecOps ecosystem. But then, what do you do with the output? It goes with deployment to production environments. And even though DevSecOps itself doesn't include everything in operations, it should be considered part of the overall ecosystem because feedback from operations is relevant. So monitoring is relevant even in production to get information back into the cycle of planning and then again back through the software factory. So often there's a DevSecOps administration team, or at least some people that are allocated to maintaining the tools and the factories and all of that. And certainly that's the way it works in the DevOps factory with the DoD. There are supporting elements. So the Department of Defense has this artifact repository, for code management, code version management, different security services, as well as things like, container repositories and things like that, and examples of tested containers. Yeah, so other than that, that's pretty much the main scope of the ecosystem. So you can see it's pretty broad actually. And even though that was DoD, it equally applies to enterprises. If you think about workflows, you can kind of think of this as how you would evolve DevSecOps solutions from having a plan, understanding what your requirements are, what are the risks from a security point of view, designing a pipeline accordingly, building in observability so that you can see what's going on from the point of view of your goals and objectives for DevSecOps, putting in place policies for each of the stage and gate transitions across the pipeline, especially for security again, and then actually go about developing it. So selecting tools, validating tools, putting in place strong code version management that's secure, and artifact repositories, create the pipeline with all the different tools and all the different connectors and tool chains with different platforms for CI and CD, for example. And then, build up CI, understand what branching strategy you're going to use. Again, preferably trunk-based branching rather than feature flag or rather than feature branching or dev branching is the best practice we'll talk about. Figure out what you're going to do at the time of a code commit. Is it a code request? What is checked at that point? Of course, all the build processes are part of CI, security scanning, artifacts management. The result of CI is usually the if it's successful, at least promoting built code that's been tested, at least as far as CI is concerned, to make it a release candidate in an artifact repository. And then, of course, the next stage is continuous delivery and deployment, security testing, Excuse me. Sorry, pardon me. Sneezed. Anyway, security testing, regression, penetration, acceptance, and release approval. I just noticed there was an error on here. It should be continuous delivery first, and then deployment. So those are actually reversed somehow. But the correct order would be first delivery and then deployment. You wouldn't normally go ahead and do continuous deployment until you got continuous delivery solid and working well and proven. So in the deployment, you would then do progressive deployments, things like blue, green, canary, feature flag rollouts, and of course, monitoring. And each of these end of stages would be considered a process gate that's measured, looking at the outputs, determining whether the outputs to that point are sufficient to continue, or whether there may need to be some remediation work before you would continue. Okay, so the pipeline itself, this is a revisit of a prior diagram from the DoD. Again, this applies equally well to commercial enterprise. It's one of the best visuals I've seen for describing all the different parts of a DevSecOps pipeline in relation to the DevOps pipeline. So we went over that before. Just to recap, during planning, you would probably do some threat modeling together with the security team. During development, practice secure coding practices, maybe do security as code, where you're building your applications. During builds, you run SaaS, running the source scanners, and probably SCA should be in here as well, software composition analysis. That's missing from the diagram. And after you have a build, then you could do some dynamic scanning. And during CD, typically you're going to do penetration testing, maybe some other kinds of testing as well. For example, security chaos engineering. When you think you've got something that's worthy of a release, then you maybe lock it down with digital scanning of the artifacts, do the release, and then decide whether you're going to actually deploy it. Just because you have something you can release doesn't mean you deploy it. There may be other reasons to actually send it into production. When you do that, you're going to have secure transfer, so encryption of any critical artifacts that are important to keep secret. For example, security configuration, so secure configurations using immutable and idempotent structures. Deployment, scanning will continue for vulnerabilities in deployment and actually into operations as well. Keep an eye out on vulnerabilities that come up that are relevant for your product, even after it's in production. And when things come up in executing patch programs, if you have a known vulnerability at that point that you can patch, that would be something that would be expedited. Security audits make sense to continue to improve and make sure that you're compliant in production. Monitoring and analysis, and complete the loop. General, this pipeline, even though it's represented as an infinite symbol there, which is typical of DevSecOps and DevOps, you can also look at it as a line, a pipeline, by stretching it out. We talked about the same diagram in the prior module, where you start planning, engineering, and development, CI, CD, and then deployment, and all the major steps along the way. This was documented also in my book, Engineering DevOps. So the pipeline preferably is fully automated. So if everything is implemented correctly in development, you ought to be able to do a commit request and have that code change go all the way through to the end, all the way into production if things were completely automated. At the same time, you want things to be visible if there are any issues or whether the metrics are being met or not. That should be visible through dashboards. Creating process automation for continuous integration, delivery, deployment, feedback, and operations should allow cohesive work across multiple physical and logical areas. In other words, you may have a service that has multiple pipelines, for example. You will have feedback loops going back and forth to help improve things and make sure you're on track. Pipelines generally create flow from left to right, like the first way of DevOps. from development to production, but also there's feedback coming back. So, and that may affect future flow. Overall, just like I said in the prior phase, in order to implement this, you're going to have planning, development, build, test, deploy, and monitor, just as you would for any product. If you're building a pipeline, you want to follow a good engineering process, just like you would for the application itself.